I am seeing also.
Yeah.
Okay, so welcome everyone to this workshop with the JIS Institute of Advanced Studies and Research have three centers. One is that is our Center for Data Science, another one is Center for Health Science and Technology, and another one is Center for Interdisciplinary Science. And today we are very blessed that among us Dr. Shyama Chowdhury is here. So he is the senior manager from IBM India Private Limited. Before that, he was deputy general manager of Samsung R&D Institute, and he has many more experience. And he did his PhD from Queen's University, Belfast, and masters from IIEST Shibpur. He has many managerial contributions as well, and he has few his teaching experience as well in Samsung R&D Institute like computational geometry, algorithm, data structure, image processing, and he has many contributions in IBM as well, such as analytic solutions leveraging sensoring data, automatic sports video highlight generation, automatic planetarium show related related things, smart TV, viewers engagement analysis, and many more. He have few, many approaches as well. And his PhD thesis was mostly performance analysis of airport ground lightning using computer vision techniques. So I warmly welcome Dr. Shamaprasad Chowdhury to start his talk. So, a warm welcome, Dr. Chowdhury.
Yeah, thank you, Dr. Aduk. I just wondered that my voice is audible properly, or do I need to be a little louder or adjust my microphone? Can you please confirm?
I think it's properly audible.
Okay.
Saptarshi, is it okay from your side?
Yes, it is perfectly audible.
Okay. And one thing, Dr. Aduk, I would like to know. So that next session, I heard from the Saptarshi, is it at 3 o'clock, right? So
Yeah,
Dr. Majumdar.
yeah. You may take like 5-10 minutes more. That will not.
Okay. So I'll be trying to finish that, but
Okay.
if it is half 1 minute or 2 minutes below her, I'll try my best uh,
Okay.
not
Thank you
to
very
disturb
much.
him. Yeah. So yes, and thank you very much for that introduction. And dear friends, welcome to this session. So let me first share my screen and PPT, and just a second. Um, sorry. So this is that I'm not sure that time to time it doesn't present. So let me just.
Yeah, you need to present your
So there is
entire
a
screen.
no. It isn't that so that it is that the privacy. Let me just. Can't. Template. Saptarshi, So I am using a Mac,
Yes.
and here that it is telling that can't share your screen. So it is asking for the system preference, and I think that the
Okay.
screen recording permission, if I give, it will work, right?
Uh, Professor Adok, any idea?
I think it should work.
Okay.
Yeah, it's visible.
It's visible. Oh yes, thank you.
Yes, it's visible.
Yes,
Yes.
thanks. It was that permission I had to. Hello, and dear friends, welcome again. So today I'll be Dr. Adok. Am I audible properly?
Yes, very much.
Yes. So today I'll be discussing some of the applications of CNN in data analytics, and so this part. I'll not go into the details of the theory. I'll not bore you, but only that few informations I'll be providing. I'm working in that the image processing and computer vision for last 20 years. Um, I worked in several different applications on the image processing and computer vision. And today I'll be discussing on the convolution neural network in data analytics. And it was obviously in the data analytics part, it mainly comes with the image processing and computer vision. I do remember when I first started working on CNN, it was around 12 years back, um, 10 to 12, 12, 14 years back. And that time we didn't have a lot of libraries, and we started to implement it ourselves in C languages. And it is a tedious job for us. And yes, partially got successful. And then also we applied that CNN in different areas. So few of them I'll be discussing at the late. But most probably we worked on identifying object in image. Now, what does it mean? So for that, and what is that image? I'll be going into that the very basic details of that. What is an image, and what is that convolution on that image, and then that convolution neural network. So just it will be a very pleasant journey, but I'll not go into the details of any theory because in 1 hour it was never possible. And so I'll be showing you that few slides, and I'll be providing you few information that will actually help you to understand why everything is required. So I believe that understanding is most important, is of most importance because nowadays codes are always available. You can go to the in GitHub, the codes are available. If you just search, you will get the Python code. So coding is not that important. So for learning of the theory, yes, you can go to that. The different channels are there. They are the professors. They will teach you the theory. So that part also I'm not going there. I'm just going to that. So in image we call it edges. I'll go into that edges and I'll explain what it is and what are the different applications you can go. So first, and in every slides I'll not provide a lot of time. It will be very short, very precise and informative. I will try my best. to make it. And so it is that the image we captured using that our camera. So that the camera, now it is a digital camera. Why it is digital camera? Because image is not continuous. It is broken and sliced. So it is the so small parts are individual parts. That is, it is a discrete, and digital means we are representing in the digital signal. Analog to digital signal is converted to a digital signal. So what is an image? Image is pictured. It is a 2D plane of 2D plane of sensor. This part. So we have that image having some impression through some optics, right? Now, in image, so that the 2D plane we have, now the 2D plane we can put a grid. So what it will be? It will look like a matrix. It will be having row and it will be having column. So it will be discrete. And each of the elements in that matrix we can represent with in some quantifiable bytes. That the bytes for 3 different colors, we make it red, green, and blue. So we call it 3-plane red, green, and blue planes. Now that image could be either black and white, gray, or color. In color, so representation, if that source is primary, we represent it with the RGB. And if it is secondary, we represent it with CMYK. So, so the 3 colors are required, red, green, and blue. It is because we have these 3 type of cone cells in our eyes for different frequency band. If we had suppose 5 different types of cone bands for the 5 different frequencies of visible light, then it could be red, green, blue, X1 and X2. These 2 X1 and X2 are the 2 different colors we could see individually if we have 5 cones. So we have 3 type of cones. That's why it is red, green, and blue. So now that it is a 3-dimensional, and the 3-dimensional we can do the transformation, then it can go to the cyan, magenta, and yellow. So any 3-dimensional plane we can represent. That image, what you will actually see, these are the JPEG image, BMP image, TIFF image, and in the mobile now GIF images. So what are those? Those are mainly compressed and animation features on that image. So if it is a JPEG image, that means it is an image. It is a 2D image. And JPEG image means it is compressed with JPEG technology. That's why it is a JPEG image. But first of all, it is an image, right? Now that if we have, I said it is a matrix. Now in that matrix, if it is 3 bits, that means 3 bits mean in each bit, if we can store 2 values, so we can store total 8 different values. So if that image is 0 to 7 different levels of quantization, so then one image can look like this. So for each of these are individual cell we call pixel, and it is that we have 8 different values. So for a color image, we have taken this image. Now, if we analyze any part, now it is looking that it is like cat. But if I just show you only this rectangle here, it's only this square here, that square here, it looks like this. Our eyes are beautiful tool that it converts the signal we receive, and finally it identifies. Now this identification that human eye can do, it can classify. It identify means it can classify that this is this is a cat and this is a fur, and this is the eyes of that cat. So we can easily classify. If this portion has been given to us, we can say, okay, it looks like cat's eye, right? So these are the, we can, if only this part of that image has been given to us, we can identify easily, we can classify this is a cat's face. But actually that image looks that on that small box, it looks like this. And each, so these are all pixels. These squares, that elements you can find, these are the pixels, and each pixel has 3 values. This is a color image, this is a red, green, and blue. So the way we can classify an image, and we can say this is a face of a cat, this is the eye of the cat, we can identify individual portion of that image. That is, in digitally, it is a little bit difficult to understand. And what are the different algorithms we can use? We can, one of that is that convolution neural network. There are the several other classifications algorithm, but today, as we are discussing on the convolution neural network, so those it is one of the classifying algorithm that let us understand. Let us keep it like that for the time being. So that in the convolution, so we are working on that image on the 2D plane, and in the representation, it is a 24-bit RGB representation of a color image that we will be taking. Why it is 24-bit? Each 8-bit forms 1 byte, and for 3 different planes, it is total 8 multiplied by 3, that is a 24-bit red, green, blue representation. So for each pixel, this may look like 128, the first pixel, 128 red value, 135 green value, and 166 blue value. For the next pixel, it looked like 138 red value, 190 green value, 132 blue value. And why these values are 138, 190? It is because we are taking it into the 8-bit, so values will be between 0 to 255. Now, so that from that the image, this is that the image plane we have actually received, and finally the signal we are getting, that is in each pixel, that it's red, green, and blue value. Now these red, green, blue values, if we plot it in mathematically, we can plot it in a 3-dimensional space. So this 3-dimensional, one is for the red, 1 dimension for green, and another dimension for blue. So each of the pixels we can see, it will be having some of its positions in this cube, in this red, green, blue cube. And we can place each and every pixels here. Now in that image, also the texture is required, and it is that one of the main reason that CNN is we use for classifying, for actually classifying that object, or actually that identifying that portion of the image whom it actually belongs to. So these are the examples of the texture, different textures. You can see this is a little bit plain, quartz, or there. So each and every textures we cannot name, but in image, these all of them, they have some of its own identification. Now in image processing, we do a filtering thing. We do applications of the filters. What is that filter? Filter is, I have a 2-dimensional image, that means a matrix. I have a matrix. On that matrix, I'll be using convolution function using a small mask or window, we call it. A function we can call a mask or a window. That is also a smaller size of matrix. And that convolutions, how it is done? Suppose this is the image I have. Now in that image, so you can see that here value is 100. So this 100, this is 100, 100, and these are the 50s. So now, if this is my convolution matrix, this is at my mask or window, you can say. So if I place it means if I place this mask on top of that image, what it will be, so that the 0 will come into 100 into this position. Now, how to calculate value of the convolutions? We can. So if this 0 comes on top of this 100, then this 0, that the top left part, it will come on this 100, right? And this 1 will come on top of that 50. Now, what is that formula? I'll be multiplying 100 into 0, 50 into 1, this 50 into 0, again 100 into 0, this 100 into 0. So this all that element below this cell, I'll be multiplying with that the cell value. And finally, I'll be summing it up. So now if it is like that, so, and if I do that sum, it will be 50. And this value 50, I'll be putting it here. So this is the convolutions we do. And so I'll not go into this part. Now, how that in computer vision, how CNN was evolved and how we worked on that at different domains. So this one actually introduced around 2000 that time, but it got popularity from 2005, 2007 this time, that convolution neural network. And hello. Can you hear me?
Yes, sir, you are audible.
Yes.
So
yes,
no,
sir.
there was some noise I suddenly got. Okay. Yes. So neural network we were using, and the theory behind that neural network was to train like that our own neurons, they are actually gets the training from that everyday life. The same convolution neural network, that the same neurons are used in some digital form and with some functionality in with some different arrangement that actually help us to classify that image into some previously known classes. So what is important here, that if we don't have that the class known a priori, and if we don't train, that we cannot identify. It is that, as I said, here it is like training of that our own neurons, like a small boy or small girl. If I teach, like, look, this is a cat, what she or he will understand, she will try to match that what is actually she is seeing in her memory, and next time she can say, yes, this is a cat. But if we don't train it earlier, but if she was similar, if she was known that how dogs look like, then she cannot say, yes, this is a cat, because she was not given any prior training, no supervised information earlier. So that the supervised information is required just to train it properly a priori. Now, for a small kid, what we have to do, we have to first identify. First we have to train that, look, this is that actually how a cat looks like. Then the kid will remember it, and next time when that she will see one cat, she can say, yes, this is a cat, right? The same training system with the digital image, that is, we are doing in that convolution neural network. Earlier, we are training with the same type of images to our system, and it is the training. It is actually the training that CNN is receiving. It actually changes its functionality or different weights. I'll come into that one day. In convolution neural network, I have suppose given that this is an input image, this A. So now I'm teaching that kid how A, B, C, or 0, 1, 2 looks like. Then what it has to be done, we have to first teach with that several such images, and then it can recognize, yes, this is A or this is any other alphabets. Okay. Now, we'll go to that neural network, but we don't have that much of time to go into the details of the neural network. But how it looks like in neural network, we have several neurons connected in a system. Now, then, if there is the input and only a single layer of neurons are there, and then the output, then it can, we call it single layer. If there are that multiple such neurons layer we have, then if we have, then we call it multi-layer. If there are the 2 layers, we call it 2 layers or 3 layers or multi-layers. So with a single layer, we can classify that object with a straight line segmenting, like a straight line segment. Like suppose we have that some functionality like and or, those type of problems we can easily take care. But XOR problem cannot be taken. I'll not go into that details. It is then today it will be a bit long. So so that actually the things we have to understand that if we increase the layers, then it can solve different higher complexity of problems. Now, in multi-layered perceptron, we have 1 or more hidden layers, and that we can use that some of that like activation functions, like sigmoid activation functions. Okay. So about that CNN, it was neurobiologically motivated a mathematical model that trains the system how human brains behaves. In convolution neural network, it is one special kind of multi-layer neural network. There are that few things that the backpropagation algorithm, I will not go into the details, but few things we have to remember that CNN, it is a feed-forward network, and the training we do in that neural network, it is the we use that backpropagation algorithm. This CNN we mainly use to recognize different objects, or like we say, these are the different visual patterns from that pixel images. That pixel images means that we have the digital image, and digital image we have that stored each of that picture element in some byte format. So that byte format we do it automatically. So that the process will be that first will be training, and that training will be will adjust different weights in the neural network, that arrangement, and then after that, if we have given any unknown image, if it is, sorry, I will not say unknown, unlabeled image, and which is actually not told what that image is, and it can identify what with his previously given training set of images with which class it matches closely. So that in classification, so we provide the input, and with this input, we do the pre-processing for feature extraction. We have the different features, we then classify, and we finally provide that output. And in convolution network, we provide that input inside that black box. We do that is feature extractions, we do the different invariance things, it is automatically taken. And then it classifies and provides the output. So what is that from the traditional image processing algorithms, why these deep learning model like that, the CNN we use, it is not that CNN gives us the best result. There could be possible that in traditional image processing, using the traditional image processing algorithms, we get much better results than any of the deep learning or the any of the deep learning algorithms like that, CNN or something like that. But there are that few difficulties. In my team, I used to work in one project, and that project was and it was a very successful project. And in that project, it was that identify how much one card is damaged. It is that by some car insurance company, and that car because when we drive, if the car is got hits, and if we take it to the workshop, they will ask us to claim for that. Sorry, they will ask us to claim for the claim for the insurance money. Now that insurance company, so what do? They send that one inspector into that workshop, and he inspects the car, and then finally say that how much we will get that value for that insurance cover. Now that our work was to identify that what type of damage that car got and at which area of that car. So we identified, we actually make the car into that several different components. It was around 50 different components in the car. It includes the wind glass, bonnet, front of the bonnet, then that rear view mirror, side view mirror, left side view mirror, right side view mirror. So there are the different parts of the car, and our challenge is to find it out how much damage the car happens. So what we have to do first, we just cannot go for finding out the damage. We had to find it out the different parts of the car first. And whenever we are finding different parts of the car, we need some technique. Now, in the standard image processing technique, if we go to solve that problem, we found that yes, we are getting much better result than we actually use their mask RCNN. We are getting that much better result. Mask RCNN, you don't have to worry, it is at some different format of that the CNN, but in the basically it is at all the convolution neural network. So in traditional image processing algorithm, we first find it out that whether it is a windshield or whether it is that rear glass on top of the dicky, whether it is a bonnet, whether it is a wheel. So we can find it out that very precisely using the standard image processing algorithms. However, what is the problem? In the POC, we found that yes, that using that the mask RCNN, that result we are getting, it is we can have much better result if we use the standard image processing techniques. It was for one particular card we did the POC. Then the problem came when that the variation of the card increased. That means first we worked on that suppose one model of that particular make. Then when we actually tried to do it for all different type of models of all different type of makes, it was more than different 25 different cards we finally worked. But for those 25, if we have to design our algorithm so precisely, it is a nightmare. Rather, we will be using some deep learning techniques, and we use that Mcafee or CNN. So actually, that what I want to tell that here, this is that actually a black box. In that black box, exactly how it is doing, we don't have to bother properly. We have to know that the technique, and we have to train it properly, and it will give us the result. So that's why that the deep learning is getting popular in that real life applications. In okay. So these are actually what I was actually talking. So from that the input images, these are that internally it finds it out different type of feature maps. It is not the feature map we actually think of the traditional image processing problem. In the traditional image processing problem, different feature could be that distributions in the histogram, maybe that different ages, maybe that different shape formats or the textures. So, but here they take it some in some different domains, so different feature maps, and we don't have to bother of that individual things when we are actually using CNN. But obviously, if we want to design something better than CNN, then obviously we need to understand everything inside. But who will be using that CNN just as a functionality in his program or her program? So CA doesn't need to understand each and every data how it is working. And this is the beauty of that deep learning techniques. Then it also that the shapes and distortion invariance, those things, it is in its property. What exactly do I want to mean here, the distortion and that shifting? Suppose the card image has been taken from that from any angle. In traditional image processing, suppose that there is the rotation of the camera, or maybe some because of some 3D some 3D modeling of that image into that camera, it is actually rotated. Then in the standard image processing problem, that is difficult. However, if we do the training properly in CNN, we can recover that, because for having that identifying that windshield of a car, or so we have to do some rotation correction. We call it skew correction on that image, and we have to make that car horizontally appear first, and then we can go for that this traditional feature extraction very easily. But for CNN, if we do that the proper training with that the different data, so that this problem can be taken care automatically. So here in that convolution, here in that CNN, so that convolution is an important step. That's why it is we call it the convolution neural network. That convolution matrix, it's actually find it out that correlation. What is that convolution is actually does? Suppose some with some matrix I'm doing that convolution here. That means it is finding relation of the pixel with its surroundings. Actually, that is that required. I need to tell you that what that relation means. Otherwise, it will be very difficult for you. That's why I gave the slides for the edges. Let me tell you. Yes. So this is that image. This is a popular image of Lena. Now, in that image, these are the edges. What edge means? Edge means there is a gradient difference. Actually, I'll not go into that term, gradient difference. Rather, suppose I am putting here a small square. Then part of that square will be on this little lighter side, and part of the square will be on the darker side. So if part of that my mask is on the lighter side and part of the mask on the lighter side, then we can find it out the edge. So this A, so that portion is become prominent. So this became prominent here. So all that, the transition is there. If there is a transition, it is getting prominent. And if so here you can see there is no transition in this. Here you can see we don't have any transition. It is a smooth. So we don't have any edges. So edge is something which is finding out the correlation of that surrounding pixels. That convolution actually finds out the correlation value. So with this correlation, so it finds it out that different features. So that the convolution that requires because we want to find its correlation. And not go into the details. Yes. So here you can see these are the features we are getting here. In this animation, yeah. So now there is one concept of the subsampling layer. The subsampling layer, it actually reduces that spatial resolutions of that feature map. Look, I have this one. You can see here what we found. It is that only that the horizontal edges, horizontal lines, all these horizontal edges, this is we actually here we receive here. And in the subsampling, if we do that, so in that features, if we do that, but so we don't have to keep that the everything over here. If we do the subsampling, we can find it out that if these portions will get reduced to this one. So it is that the sampling, if we so that in the quantization, we actually on that the value we put it into the different range, and on that the sampling, that means if we want to do a smaller image, what we'll do, we find it out if there is any prominent features on a larger portion. So from here we can get this part. So you can see, so this A, after a subsampling, we got this image, and this is at the broken A. But when we are doing that subsampling, so we found almost very similar type of features. So this is that one example of that subsampling. Like when we are actually training the system, so when we actually it is learning that system, what we are doing, we are identifying that the small portions, and these small portions is actually get this CNN, it actually learns. And we can have some like that functionality. It is not that easy, but we can identify, yes, if this value goes above, we can identify this is the tick. Like we when we actually worked on that this project of identifying damage into a accidental car. So over there, we found it is very similar that tail light with the upper portion of the bonnet, and it was very difficult to identify. Also, we faced that problem in detecting that the side mirrors. So side mirrors and that headlights, it was, in many cases, we found it is same. And it was because of the different color of the car and that different lighting conditions when that the image was actually taken. But those are the different problems we faced. So I will not go into the details. Yeah. Let me go to that. So this is at the convolutions. Yes. Yes. So there is one concept in that convolution neural network, that max pooling. It is that after having that convolution convolved value, then we can define one function that from a window to take which value. From that the features, we can take that the highest value on that the feature value. Like we have this one, and for that max pooling, this filter 1. So with this filter 1, we can take that value out of here. I'll show you. Now, if I take that the maximum value, so it will be from here. I have this square, and from that square, we have the different value after we got after that convolution. So we do the max pooling, we are taking that the maximum value. So here, this one, I have that maximum value 0. Okay. So this is that actually representing that each value is representing that square. So this 4 value is representing this 4 square. That is at the max pooling. So this max pooling, we do the subsampling to have a prominent feature values for here, you can see. Now, a CNN, it compresses, it is actually time to go into the details. Okay. So that in whole CNN, what we actually do, we do the convolutions, we do the maximum pooling, And with that, we create a fully connected feed-forward network, and we initially train with different images of that particular class, and then it identifies that what it is, an image, what it is about that object, whether it is a cat or dog or something like that. So you can have that code very easily available. Uh, that convolution neural network in Iraq, you can find it. So these are the few functionalities. I'm not going to the details. Yeah. So it is not that only that images we work on that. We work on that speech recognition process also. So this part for the speech recognitions, also we found that CNN gives a very good result. We use that CNN in one of the applications of our in my previous organization, Samsung. We built that identifying automatic highlight in soccer match. So on that we use that CNN. So actually when that in soccer match, so on that audio, if you give little more emphasis, you'll find that when that it is of very important situation that people are that one team is scoring a goal, so people shouts. And also nowadays it is a problem because we don't have the full stadium full stadium viewers over there because it is restricted. So for that also we create to have that same kind of ambience with some loudspeakers. However, in generally, so if it is a full stadium, so everyone is watching that match. So if there is a situation of the goal, people shouts like that. It is a goal like that. Also, we have that the similar type of differences when it misses. So they say, oh, like that. So that only with that the voice level, it was tried to work on the voice level, but in the voice level we found it was not that much possible. And then we use the CNN to identify if we can have something better. Yes, and that time that CNN it worked very good for us. So here, so it is the time is almost over. We have just most of the slides I didn't prepare. Those slides are borrowed from these sites. I have given it the references, and thank you very much for the time. And if you have any questions, I believe we have at least 1 or 2 minutes for that.
Thank you, Dr. Chowdhury. So I'm asking the participants if you have any question, you can lightly ask, or still, if you have any question later comes into your mind, you can email us to forward to the speaker. Yeah. So once again, thank you very much, Dr. Shamaprasad Chowdhury.
Yeah.
And
Thank you very
all of
much.
the participants also enjoyed your session, which was quite thoughtful.
Thank you, Dr.
So our next speaker is Professor Arun Kumar Majumdar. He is one of our Emeritus professor at our Center for Data Science, JIS Institute of Advanced Studies and Research. He was a professor of eminence and pro-vice chancellor of Adamas University. Before that, he was in IIT Kharagpur for almost 40 years. There, he performed. He was deputy director and head of the Computer Science and Engineering Department. He has completed many government projects and he has a vast area of experience both in research and academia. So welcome him warmly. Professor Majumdar, so you can start your session now.
Okay, thank you.
Sir, Chandranath, sir.
Chandranath, thanks now, and also thanks to Shyama, who just gave you a talk on the applications of neural networks in image processing. So, since this is a series of talk related to the applications of data science, data machine learning techniques in different arena, and I have been asked to discuss with you about applications of data sciences, particularly machine learning, with reference to the cyber security. Now, while I was asking about the background of the students, or the students who will be participating here, and I was told by Chandranath that you assume them to be final year BTech students, mostly from CS, but maybe from other discipline also. So in my talk, I assume that you have some background on the computer networks, but I will just very quickly go through the basic aspects of that. And also, I believe in the next lecture, Professor Rai will be talking about data security fundamentals. Is that the case, Chandra?
Yes, sir. Yes, sir. Fundamentals of data security.
So in that, he will be definitely covering some of the topics which are relevant here also, particularly with reference to the computer networks. So that part also I'll skip, and then quickly go into basic aspects of how to protect your environment you are working on, and what are the techniques that are used today or for protection, as well as for detection of the infiltration or intrusion. And it is there, as we will see, that machine learning techniques are being extensively used. Okay, so I begin my presentation now. So my talk is basically on machine learning in data cyber security. Can you see it?
Yes, sir. We can see it. Yes, sir.
Okay. So now when we talk about any machine learning in cyber security, the topics that got to be discussed are who attacks networks, and first of all, why do you need to study it? You know that in cybersecurity means that in every day it is of immense importance in the world, and you're all familiar with that. Your banks, your bank accounts, or your any other credit cards and everything, or computers are being attacked all over the world, and the amount of money that is, or money or other assets that are often compromised runs into millions or even billions of dollars. So therefore, cybersecurity is of extreme importance as an application for any network environment or computer environment in which we are today confined because of the more so because of the pandemic. So next questions that often will be asked that who attacks networks? Now there are many ways of saying it. It can be, this is called the classes of intruders. It can be hackers who deliberately, hacking means they try to penetrate your network and try to access the resources. It can be a malware or a virus. All of us know that our computing systems are often virus attacks it and destroys the files or destroys the system itself. We can have clandestine users who can be suddenly somebody gets access to it. So basically, it is a significant issue for any network systems is hostile or unwarranted access either by a network or local. You can be attacked by a person in your environment. Your own people can do it who are not authorized to use it, access it. That you have a sensitive data. There's nothing coming from the network, but person within your organization is hacking. And when you are trying to deal with intruders, you must be able to handle at various levels of competence, because some of them may be extremely knowledgeable about the network. Most of them are, and they may be very skilled intruders. They can design a penetration systems and attack your system. And so what are the goals often of the, varying the levels of competence may vary, maybe a completely a novice person or maybe extremely competent person. And we have that motivation of the intruders may vary depending upon what they want to do. Somebody may be just like in government networks or military networks, this is a kind of cyber war, or it can be in the banks, another thing, it can be a financial resources, it can be in a hospital environment or any other kind of service environments. You want to destroy the services. Like there was a recent attack on ransomware where they blocked the pipelines. It can cause the tripping of the electrical systems. So there can be many motivations. So since I don't have time, I don't want to go into all details of it. But as I said, there may be millions and billions of dollars involved, persons involved, and enormous. So as I said, they can be various level of competence, and often, in many cases, they begin with trying to acquire your passwords. Many of these systems are password dependence, passwords, or it may be also your identity base. That is, I want to say, suppose you have a picture-based access control, photographs. I can try to replace your photographs, which is being used as a entry passcode, and replace it by somebody else's. So the next thing that you want to do is that, as I said, goal is often access the passwords. Now, how do one begins with it? Most common task is that someone attackers, because I'm using this is very common. That is, attacker somehow knows your login name, and then tries to guess the password. So what did they do? They try to use the default passwords that are, because many of the systems has a password much when the system is originally shipped. The passwords can be very small if you are not careful enough, you have not hardened your password. It can be, many of the people use common words in dictionaries. It can be based on variations of your name, birthday, phone number often becomes password, because many of us cannot remember all kinds of passwords. Often if I have two, three passwords, it will be something which I can always recall. So it will depend on the success of the passwords users has chosen. Though many of the service providers, whether bank or anybody, tells you to use a very strong password, often we don't, and it has the survey indicate that in many cases of it is not so. So next thing is that, therefore, what are the types of network threats? So we have a network, and what are the types of network? Network can be a data, we can be accessing programs or data at a remote host. Somebody from sitting here, for example, in say, let us say JIS college, wants to access the data from the JIS university site. That's a remote accessing programs or data at remote host, which is at the JIS or JISR system. So we can, if I can access the programs, I can modify the program. It's another type of threats. So one is accessing, another is modifying it. And then running a program at a remote host. That comes much more, because in that case, you can, particularly in security environment, military environment, it can even, you can initiate a firing of a missile in the worst case. Again, the threats can be data while it is being communicated. So in that case, you can trap the data while it is being transmitted, or you can identify the data in transit or insertion of data into communications. These things often happen in a wireless network where interceptions do take place. And but here in my talk, I will not talk on the details about this part. So next thing is that how do you classify the networks attacks? There are many ways. One of the most common is called the denial of service. It is an attack if somebody wants to hack your system, denial of service to my talk today. Somewhere or other, if I can hack the server here, or rather deny any other user to access it, that will be treated as a denial of service. It can be any legitimate user also are finding it is difficult to access it. So you want to access the web services web page of the JIS. You will go on trying to trying to access the web page of JIS. You are unable to do it because the connection to the server has been already flooded with the requests. There is another kind of attack that takes place called probing. That is, you want to get access about the information about the network. And one of the system that probe that you may have seen is called the ping. So pinging, that is, you try to give an IP address and pings it to the destination. That's a probe. And the another types of the user to root. So an external user like the student at a JIS college wants to access the root as the root to the directly connect to the root of the JISISR server. Similarly, remote to user. User is already is a person inside the system who has access to legitimate resources. And so therefore, once he gets access to that legitimate user, then he can, since the user will try to access the privileges of the internal user, and this can be sometimes that very sophisticated one. You can install a sniffer which accesses, which basically looks at the internal traffic and guesses the password before compromising the entire system. So access a particular user who is lax enough, install a sniffer to sniff the passwords that are that are there when somebody else is trying to access the network server, or he is trying to, and then get access to this. So basically these are the 3 or 4 categories normally the network attacks are done. Then we see the number of types of networks attacks. You can be impersonations, that I said somebody impersonates or looks at the hacks the ID of a person already and says that I am this person. Like you see today's TV always saying somebody doing a the fake vaccination program by impersonating himself as the deputy commissioner or some commissioner of Calcutta Municipal Corporation. Spoofing is also somewhere or other you change your IP address so that it will look like something else. I mean, it is a legitimate address. Now, these are the different categories of, say, we can have a message identity confidentiality threats, message integrations, web attacks, which are the most common, denial of service, and then distributed denial service. This is more common because there may be multiple multiple attacks from the different places, and which ultimately leads to the denial of the access to the, say, JIS website. So this part is there. So I just mentioned this thing you have seen. Normally when you talk about networks, we talk about IP or IP address frequently, and it is the packet header, is a 32-bit header, the weight long, and the IP addresses are 32-bit. IP6, you will have a 6-byte long. And we then, let us look at the network security controls. So we have the different types of attacks and how we protect your system. So one of the most common method of threat analysis and implementation strategy will be encryption. Professor Rai will probably talk about the different encryption techniques. And we can have a different types of encryption. That means whatever you say, the data or header, it will be encrypted. Like we can have a link encryption, which can be end-to-end, that everything, header to and to the data along with the IP data, everything is encrypted. We can have a virtual private network. We can have PKI, stands for public key cryptography in systems and certificates. SSH and SSL protocol, the secure socket layer and secure socket header. I believe Professor I will be talking if necessary, because if you want to connect to a secure system, you cannot just enter into a work in a secure system. You will not be able to do simple telnet. Simple telnet is vulnerable, So you want to do a remote logging, you will be going through the secure socket layer and secure socket shell, where your credentials will be verified in terms of the certificates, and it will be encrypted. Many of the services offered, even WhatsApp offers end-to-end encryption. And IPsec protocol suite is basically a security suite which is necessary. You can have your entire encrypted mail system to be encrypted. And message content integrity controls are basically error correcting codes and cryptographic checksums, which are basically to check whether the message content had been somewhere or other compromised or not. And the strong authentications are one-time passwords, or you can have a challenge range response. And Kerberos, I think Professor I may talk. So network access control. So we have said that what is the network's access controls are, and now how do you implement it is one of the simplest way, or the way is done through the basically what we call the firewall. So we'll come to that. So basically access control means you want to protect your system somewhere or other. You will not allow the internal net IP details to be visible outside, and to protect it we define some sort of a filtering policy, and these are called access control lists, which are placed in the router or in the firewall. And so the most external router, which you call our networks, has are basically defined what are the type of machines, internal machines that you can access. Some of them may not be totally accessible and inaccessible after the firewall. Some which are kept in the demilitarized zone are allowed to be accessed, but again they will be like, say, your web server may be here, will be here, and that will be not be allowed to access. I mean, by not anybody will be allowed to access it, but only from some domains it will be allowed, and that is defined by the router and the firewall here. So networks access security tools, this is where slowly I was telling that I will come to, is called there are two actually. Honeypots is basically a deceptive to decoy for detecting to the intruder, to trap the intruder, but the firewalls and the intrusion detection systems constitute the bulk of the security infrastructure that are being used. Now there are different kinds of firewalls are used. Some are network firewalls, which essentially maps the IP tables, which are the firewalls. The IPs, internal IPs will be mapped to external IP to somewhere else, but not directly. The external user will not have the idea of what is the internal IPs are. And so that is called the network address translation. The term is called network address translations. Internal address is changed into something else, like say proxy server does, or the port address translations. And there are some applications level plus, like say restricting FTP services through FTP access files. I hope you know about FTP. It's basically file transfer protocol. You want to get a file from an external source, and you will not be allowed to have access to FTP unless you are authorized to do so. So the types of firewalls are important. In fact, slowly we'll be going how intuition in machine learning comes into picture. So we have types of firewalls can be. It will depend on whether communications is a basic firewall. So the communication is being done between single core node and the network, or between two or more networks. So we have two networks, one network of JIS ISR, another network may be JIS University network. So there may be two different networks or IIT networks. There will be different types of firewalls to protect it. Whether the communication is intercepted at the network level or at the application. If you remember OSI stack of the networking, either it can be at the network level, that means TCP/IP, TCP level, or the IP level, or at the application level, like in the case of HTTP. Whether the communication side is tracked at the firewall or at the node. So firewall essentially acts as a packet filter, meaning only simple packet filters are, that is, you only allow some packets coming from some allowed address to enter or go out. So like here, you have an internet, you have a packet filtering firewall. It will filter out, it will block some of the IP addresses that are coming. And this is the private network. So this is the perimeter, this is the packet filtering firewall. Or we can have, that is the circuit level gateway. You have two networks, you want to filter them. You have this is the outside host, this is the inside host. And here we have a gateway which permits only few to go in or go out. Packets. Now, as such, these types of firewalls are maybe only not state dependent. That is, it doesn't depend on what have been done. Suppose you have done one blocking, you have filtered them, but there is no concept of the state, that what the firewall did in the previous state, now it will do something else. But that state being particularly in case of complex access control, we need to keep what the firewall did, whether the firewall it was allowed to enter sometimes in the past or not, and what is the current state of this. So the in case of a stateful firewall, keeps track of the state of the network connection, for instance TCP streams traveling through it. The firewall will be programmed to identify legitimate packets or different types of connections. So packets which will be matching a known connection state only will be allowed by the firewall, others will be rejected. For example, if a packet which also contains the type of protocol when you use it, it's a say IP packet, and if it is only for HTTP applications, it will be allowed, but if it is for FTP or logging, then it will not be allowed. So stateful firewall works is maintain significant attributes of each connection from start to finish of its network. These are collectively called the state of the connection. May include such details as IP addresses, ports involved in the connections, and sequence of packets traversing through. So the packet filtering is is blind to what is the state of the network is, or what is the state of the earlier connection was. So depending upon the state, it will block or it will allow. So stateful firewall therefore depends on three-way handshakes with the TCP protocol. Again, I said that this is at the session layer, a TCP session. When a client initiates a new connection, it sends a SYN bit that is the first time connections, and all packets with the SYN bit will be considered by you as a new connections. Now, if the service which the client was requested is available on the server may reply with an acknowledgement. Now, if the client will then respond with a packet in which only the acknowledgement bit is set, and the connection will enter the network. Such a firewall will pass through the ongoing packets through it, but only allow incoming packets if they're part of the established connection. So once a connection is established, whether it was restricted or not, it was allowed or not. So examples of some of the stateful firewalls that are commonly used are Cisco PICs, which is most commonly used, Cisco or Juniper. These are the large network companies, and almost all big the networks are protected by Cisco or Juniper or some other firewalls. But the Cisco PICs is in IT we used Cisco PICs as a firewall system. Now, attacks on packet filters. So the question is, therefore, we see that there are firewalls, and so you can feel safe, but the firewalls can also be attacked. So this is called use a fake source address, such as using of a trusted address already known, and most frequently used during the source routing in the DNS attacks. That is the denial of services. So attacker sets a route other than the default route, blocks source routed packets, and what will be the defense against it? So in this case, add filters on the gateway router to block packets from outside to the network with the source address inside the network. This will prevent the network because the acknowledgement then outside person, like a person from JIS college, sends a packet which has a destination address as the one inside it. Then acknowledgement with the then the acknowledgement will be sent to this source inside the network to prevent that net attacker within the network from launching IP spoofing attacks. Again, the IP can be fragmented and others. An application level firewalls are capable of doing deep packet inspections in reasonable time. These proxies can be read the data port of each packet, data part, and in order to make sure that the intelligent decisions are made. So, so basically, these are some of the very common techniques that are used by a firewall. But then, application level firewalls become more and more complicated. So instead of going it, let's look at, because our target is how the machine learning techniques are being used in this example or environment. So let's see that what we are saying. If we know that these are the addresses, so I will allow, or these are from the packets coming, I will block it by firewall. Many a times we don't know even that. And second is that if somebody uses spoofing, then I may be hoodwinked, the firewall will be hoodwinked to see that that there is no external attack. So the next thing that we'll have to look at is let us look at a typical intruder behavior. So intruder behavior, we have a common user who are otherwise safe. They have a certain kind of behavior. And we have a profile, we have somewhere or other profile of an external intruder. We believe that the behavior of the intruder will be somewhat different from the legitimate users. So it is this, therefore, if you look at that probability density, the probability of certain kinds of actions at a time. So if you look at it, the profile of an external user, though may overlap to some extent to of the legitimate user, there will be some differences. So it is this difference which they will say that this is an intruder. Like for example, when you are trying to detect the credit card fraud detection, this is a common problem. The common users, you know the profile of a particular person's user's credit card behavior. That is, he buys something from, say, ShopX, from a, say, from a clothing store with certain problem on certain day, and then the uses his credit card to buy so let's say some bags or travel attachments. Then he or she goes to the another shop to buy some household items. So all the time he is not spending more than, say, 5,000 rupees. So 5,000 is upper limit. Normally he will he will buy about 1,000 rupees, then followed by 2,000, or maybe then drops it to 500, 1,500. So the typical behavior profile of a user will be something like this kind of. This is the probability density. The probability of the user buying more than 10,000 rupees items on a day is this. And then, but however, if a unauthorized user, a person who has stolen the credit card, may try to buy some of this kind of low, and then suddenly he hits high, very high, or high about, say, 8,000, then there will be a violations. So this is the behavioral profile which has to be somewhere or other tracked and find out whether, to what extent, where they differ. And so therefore, one of the most commonly used technique of today, aside from the firewalls that I've said, which is the standard firewalls like, say, packet filters and others, which have a fixed set of rules to identify block the unknown packets coming. So how do you detect intrusion? And there are two main approaches of intrusion detections. These are called, can be statistical anomaly detection, and they can be rule-based anomaly detection. So here, in statistical anomaly detection, naturally we define the threshold and profile base. I've shown the profiles. So we have a profile of the normal behavior and profile of the unauthorized user. Now, if I can find out the statistically, to what extent, how many times the person has bought items more than, say, 8,000 or 10,000 or 20,000. Has he bought anything 20,000? So these are statistical nature. And what will be the threshold? So when we'll say that that is an anomaly. If a person buys in a credit card, one day he buys items of 10,000 rupees, and will you consider that as an as a attack on a stolen credit card? Because that way the user first time when he tries to buy something expensive which he likes cannot do that. So therefore we have to see that what is the normal behavior of the person over a month or 2 months or a year, and then look at what happens, what are the outliers or the things that happen today on a particular instant. So this can be based on a threshold. So I'll say that the person will never buy anything beyond 30,000. That's a threshold. Or it can be profile based or rule based, anomaly based on previous use and patterns, and then a notification of the person. So the statistical anomaly detections are based on threshold detection, the count occurrences of a specific event over time. If exceeded the reasonable value, assume intrusion. For example, if I find that I have used the credit card, or the event is I have used the credit card most of the time within 8,000 or 6,000. Although in a month they may add up more, I may have used it for once in a while to say to 10,000, and then you define that is the only once you have done it. If exceeded the reasonable value, assume intrusion. So if there exists in a month more than twice the credit card usage in my name with the 20,000 or exceeds 20,000, then I consider that it must have been compromised. Essentially it's a crude approximation of the behavior. The other is profile based, which is characterize past behavior of users and detect significant deviation from this. It can be multiple parameters. For example, profile can depend, the usage behavior may depend on the time of the year. I may have used the credit card more so during, say, Durga Puja, or while I am traveling outside for a short period of time, but normally I do. So therefore, the time of the year or the period on which this was used is a factor of my behavior, and also it may depend on, say, for example, I may have gone to some medical treatments. That's also a time dependent or other conditions dependent. So these are the statistical anomaly detection thing. Now, in order to, so therefore you can see, therefore, how do you decide it? It will be based on some records you are keeping. And the records are audit records, the basic data set for intrusion detection. Say it can be native audit reports, that is all the credit card, the company who is issuing it, my record, keeps audit record, or your system, computer system. Records can be kept, what are the types of networks, the IP addresses are coming. So part of all run multi-user operating systems. So any operating system, the functions, as we'll see later on, keeps a record of the type of accesses that have been, or operations that the program has performed. And they are kept an audit of it, audit file. And detection of specific audit will create a specifically offer to collect wanted information. For example, I may keep a record of the some database files, how many times that database files was used, say credit card profile database has been used or not. So this is a kind of thing. Then audit record analysis is analyze records to get metrics over time. So it can be counter, gauge, interval, timer, resources used. So they use various tests of these records to determine if current behavior is acceptable. Some of the tests you have learned is based on the mean or standard deviations. It can be chi-square test. And if it is an internal sequential dependent, then we can have a hidden Markov model or time series. For example, time series data can be, for example, the monthly data of your credit card usage or monthly data of the number of IP ports that have that an HTTP ports server has been accessed and in what sequence. And here the machine learning approach will be used. So typical records that are kept or the information that are kept, it will be login frequency per day on time in case of a systems used, frequency of logins, how many times a user has logged in, how many times the time series of the last time since last login, and elapsed time per session, how long the user has used the system. Just a minute. Sorry. So therefore, if you look at these are the very critical parameters. That is how many times that user has logged in a day, or in case of a password guessing, he may try to log in under different passwords with the different given passwords and try to guess the passwords. So the frequency of login at different locations, it may be from the same place or from different locations, and time since last login. So quantity of output, how much output is, we can mean and standard deviations of this data. Then session resources utilized in a particular session, what are the resources you have used, whether you have, what are the files you have used, what are the network or these of the IO devices that have been used here. So password failure at login, this is very important when the password guessing takes place. See, if there will be, if you try to guess the password by repeatedly changing it, there will be failures. And so what will be the average and mean value? And then if it is a person who is a legitimate user for what is passwords wants, then he or she will be, that will be allowed. Say for example, we can say after 3 password failure you are blocked. You cannot. You have to try, or you will have to be sent, an OTP has to be sent to your mobile phone, or to your, if you want to change it, or to your internet, to a mail address. So these are some of the measures that are the features. These are basically features that will be used. And See, command on program execution activity, that is execution frequency, how many times you have used database access, you have tried to, how many times you have tried to run the SQL query, and how many times you have been denied. And the file access, as I said, read, write, create, records of read or written data, and so on. So these are some of the features that are very important in trying to gather statistics or gather create the behavioral profile of a normal user. Vis-a-vis, it will be the intruder. Now, so once you have an idea of what you are going to look at, you are trying to model the behavior or trying to get certain statistical properties of the behavior of the user, of a legitimate user, and then also you are all simultaneously doing it for the intruder, then find out the difference between them, which can be based on statistics, like, or you can do a chi-square test or those kinds of things. So therefore, intrusion detection should detect a substantial percentage of intrusion with few false alarms. This must be the case, that you must, if too few intrusions detected, it will be false security. If too many false alarms, you may waste lot of time. False alarms are detected, and then therefore it's a hard problem, and often maybe many commercial systems fail to meet this expectation. You must remember, these activities of detection, acquisition or acquiring data, detection of it or comparing it, are requires some time, execution time. And you are looking at a volume of number of users trying to penetrate your system, maybe in thousands, or maybe even particularly in denial of service, maybe packets coming may run into several thousands. And that has to be done in a very fast, in a very small amount of time. So all these intrusion detection techniques, or the firewall filters I just mentioned, they do it in almost as much as the time required for normal the command execution time. That's within a few less than a millisecond even sometimes. Cisco picks can handle thousands, millions of attacks. So it's not merely the problem here is not merely the detection. I do not have infinite computing resources at my disposal for detecting systems. Neither we have the large amount of time available. Because if you take too much time to detect the intrusion of or the credit card fraud, the person will go away. So that time is also important. So now let's look at some of the anomaly-based detection system. I've given a reference which appeared in 2019. So anomaly-based detection systems are categorized into two types of system. One is called the misuse detection system. Another is called the 2D anomaly-based detection. And misuse detection systems are often called the signature-based detection system, where you recognize patterns that describe suspect collection sequence or activities of a program that can be possibly be harmful and stored in the database. For example, most of you have heard what is the signature of a virus. Normally, how do you say that you have been attacked by a virus suddenly? So what happens, the virus when there is an attack, then the signature of a virus is, or known viruses are already available to the antivirus companies, and they create this database of the all known, or whatever the known viruses are. So the signatures of the known viruses are known. And when an unknown virus comes, or a virus attack comes in, you first compare with the signature of the existing virus detection systems. You compute the signature of the known attack, and then compare them. And if they do match, you say that has been attacked by some virus. In fact, the person who became famous in detecting the antivirus, Mcafee, recently committed suicide. Probably have heard that. There's a Mcafee virus, antivirus system. It was a very popular, and it still is. And there are companies called Norton Antivirus Systems or Mcafee, and they are essentially use the signature of the virus program or the wave code, and compute the code, essentially some of the specific features in it, that is how much time it will take, what are the resources it attacks, what are the code sequences are, and based on it they compute the virus. So if they recognize patterns, describe the suspect detection sequence, they can be harmful. Then now the advantage of it, identified patterns improve understanding of the network behavior. It can handle sufficiently large number of attacks which are already maintained in the database. So that's why you will find that the companies always say that please allow me to update your virus, update the virus signatures, whether it's a Microsoft or Google or anybody. However, the limitations are can only detect intrusions whose attack signatures are already known in the database. So therefore, for every attack, its signature is created. Attacks whose signature are not present in the database cannot be detected. So therefore, such techniques can only be used only if they are known as a specific set of expressions and string matching. Essentially perform string matching. So that's the type of data analysis department. Signature attacks only work well against fixed behavioral patterns. They will fail to attack with human interventions or attacks with inherent self-modifying behavioral. It's not like the computer virus we are talking about are not like your COVID virus, which itself changes, mutates. Of course, you can mutate a computer virus, but that new virus signature will be different. Then, so IIST, therefore, compare characteristics of the system anomaly based. In case of a threshold metric, when the statistics deviate from the normal and threshold, sound alarm. Example, number of failed logins. You can use the standard statistical based mean and standard deviations. So all user events in a system, which is the time periods of user activity, response of usage patterns, profiles. And you can, if you can data, you can compute a Markov model of it. So based on the state, expected likelihood transition to new state. If a new probability of event occurs, when it is considered suspicious. So capture therefore how the anomaly detection takes place here, capture the average behavior over time, but system behavior is not always average. So correlated events can have dependencies. So machine learning approach here comes, training the data obtained experimentally, training your network to your either machine learning algorithm, which can be, as we'll see, it can be neural net, or it can be SVM or anything, which trains data set with available data set, and then gets the average, get the neural network is trained to detect this kind of behavior, and then when a new data comes, it should be able to calculate. And so therefore, here is the machine learning will be coming. That is, your machine will, or data model will be used to learn, train your detection network. So basically, misuse does a sequence of instructions violate security policy. So some well-known, capture known violating sequences like intrusion signature, but it will not be. So you can have a number of toolkits for it. So rootkit is one. Alternative approach, it can be state transition approach, a known bad state transition from attacks, which is modeled by a Petronet, and capture when this transition has occurred to user to root. So user to root, essentially, how does the user, that is hacker, tries to gain access at the root administrator passwords of control. So the sequences are like this. So does the sequence of incident violate system specification? So what is this? Need for formally specify operations potentially critical code. So we must have a trusted code and verify post conditions met. So typical IDS systems are anomaly dissections are network systems which are called NIDS, and misuse detections are, that is, detections in our time, sometimes called idiot, and they use Petronet. And this is an ASAC systems, which is rule-based system. And we can have a mixture of them, of the IDS, and we can have an IDS system like this, similar to audit system. And we have a big companies like Cisco and others have developed IDS. Cisco ASA is a system like that. So we have a similar to audit system. So you log events, analyze events, and in a distributed environment, you can have a multiple agents which will be acting as host 1, host 2, so like this, and they will communicate with the director to notify that. This is the architecture of a typical IDS system. Or we can have a distributed IDS system. So as distributed IDS system is the LAN monitor, host, and these are the agent module. And then we have the complete general manager. So the statistical mesh techniques used as a mean and variance on normal transaction to build a normal profile. So statistical tests like say chi-square tests are employed to determine whether the observed transaction deviates from the normal. Like say we can have a mu plus 3 sigma plus minus 3 sigma rules. Within that we say that it is pass, otherwise no. Sigma is the standard deviation, mu plus mean plus 3 sigma rule, that when the observation may be observed normally. So it's not that you know exactly the values, but you are allowing statistical variations to the tune of this. So ideal assigns a score to the transaction whose profile deviates from the norm if the score reaches the threshold as alarm is. This is a standard statistical based technique. They do not require too much computations, and many of the commercial systems do support this test. If the threshold is based on an account event occur over a period of time. Now we come to the machine learning based system and learn features in executable file in the process behavior. And the endpoints may be your endpoints may be workstation, server, and container, cloud instances, or even IoT device. So every endpoint has its own specifics, but the tasks are common. That is, you can use a regression technique to predict the next system call or executable process and compare it with the real ones. So classification will be used to program, usually the idea as malware or spyware or the ransomware, and clustering of malware protection systems to emerge as an attachment from outliers. So techniques like neural classifications of malicious scripts, a study with JavaScript, VB script is there. And URLnet is a learning URL representation with deep learning and malicious URL detections. So therefore, classification, network anomaly detection, supervised classifications, these are mostly used in the advanced security applications of Cisco and Juniper networks. So builds an expert extensive knowledge of the characteristics of the network's attack. An attack with a known pattern signature is detected as soon as it is launched. The classification is based on to create normal traffic that builds the knowledge base and consider the activities that deviate from the knowledge base as anomalous. So these are the techniques used are support vector machines, Bayesian network, and neural networks. Such IDSs have capability to detect attacks which are completely novel, assuming they exhibit a simple deviations from the normal traffic. By what do you mean by normal? You can do the statistical profile, look at the statistical features like mean, standard deviations, and so on. And then use a classifier, either support vector machines or a Bayesian network or a neural network. Then we have this network is the most major parameter in which the anomaly detection systems rely on. So IDS engine must be able to understand and process network protocols at scope. Defining the rule sets of the KV is one of the key drawbacks of the anomaly detections. What is the normal behavior? Normal capture the network behavior and detection. So the efficiency of the entire system, if your IDS takes too much time to capture the network behavior, it will not be possible. And neither you will be allowed to use the testing of the rule sets from all the protocols. So major benefit of the network is about the scope of the detection. However, this type of approach could also be feasible. And you can even look at it. A typical, this is a paper which appeared in 2016, is an anomaly based. It is an anomaly comes and you point, that can be point anomaly, it can be collective anomaly, a set of people simultaneously attacking your network using DNS, or it can be contextual. So it can be contextual means it can be on the date or the day of the payday, or it can be something of that kind, depends on the context in which it is done. So the type of attacks can be, as I said, user to root to local, or DOS, denial service, or probe. And then this is classified into attacks with an anomaly. So essentially the anomaly is detected as point, collective, or contextual. typical architecture of intrusion detection network is that you have the IDS environment. This is event monitoring. Event monitoring may be the number of logins that are taking place, or number of the intrusion coming from blocked IP addresses or IP address which are suspect, and monitoring. What is a monitoring model? And then you perform the analysis of the model and models, and after the analysis you have the response process. And this is the data storage of the database of the existing old data sets that you have. So anomaly-based detections can be, as I said, it can be user intention verifications. It can be data mining methods can be used with the data that you have collected. They can be classed, then you can cluster it, associative group discovery, classifications, and k-nearest ever. Particularly in case you don't know anything about that, you can use an unsupervised learning technique, and you have a decision tree. And the statistical method based can be Markov process, operational, multi-value, multivariable statistics, statistical moments, time series, and univariate. It can be univariate. And the recognition system can be based on finite state machines, descriptions of scripts, that is the some JavaScripts or other which are used for acting expert systems. And machine learning based can be Bayesian networks, scientific genetic algorithms, neural networks, fuzzy logic, or outlier detection. So these are the different anomaly detection techniques that are used today, and some of them are deployed even in the network process. So the advantage of the statistical technique do not require prior knowledge of the signatures of this attack. So they can detect zero-day attacks. Since the system is not dependent on the sensor, the updating is not required, and it is easy to maintain. If it is made on completely on signatures and matching or not matching, then it's difficult. Every time the signatures have to be updated. The intrusion detection were captured over a certain period of time and can be identified and are good detection DOS attacks. Disadvantage, they needs accurate statistical control distributions. The learning process maybe takes days or weeks to become accurate or effective. Some knowledge-based techniques used are based on extract knowledge from the specific network and system vulnerabilities. Acquired knowledge is used to identify the intrusions and attacks. Network that generates its alarm as soon as the attack is detected can be used both as misuse and anomaly. So they have a fairly good accuracy of the gathered knowledge base. It helps security analysts to take preventive or correction. They can be very, very fast if it is pure statistics based. So data mining based, as said, the knowledge based IDS can detect the attacks whose patterns are known, but it's difficult to detect the insider attacks. So you can use the data mining based. All of you have heard the data mining can be used to extract useful patterns and also be previously ignored patterns from the data. So techniques used for data mining are clustering, associate rule discovery, classification, k-nearest over, and decisions of free methods. They can use high dimensional data. They complete can handle the pre-computed models are designed in the training phase, and then in the testing phase you can use the first. So therefore, model is created during training phase and then generate the system unsupervised. So disadvantage is that identify anomalies by product clustering and is not optimized for require high storage and are slow in classifying due to high dimensional. So classified that machine learning and soft computing support vector machines, neural nets. So these have high algorithmic complexity and long training times. And so this is the problem, because particularly if your network is very highly used. So what are the intuition detection data sets? As you have learned that all these things depend on having a data sets of your normal behavior and then compare it with the abnormal or on attacks. Now, most of these times, since labeled data sets are not available, most of the companies will not release your network traffic data easily. And since label, so therefore with the appropriate label, but this IP address was an attack IP, this address, this action was for the normal one, and that the companies will not release. So there are some public databases, so therefore which may not be unlabeled. You may get an unlabeled data set, but not the labeled one. So you can use unsupervised learning technique and cluster anomalies. So some IDS systems have precision and recall values after testing, and so reported is about 92% precision and 99% recall. Yes. And some of the privacy organizations do not, so therefore we have to depend on publicly available data sets to develop your algorithm. So among them, the most commonly used is the DARPA or KDD from DARPA MIT Lincoln Laboratory. They were done in 1999 and then subsequently updated. And they have a training, KDD dataset contain 24 traces of 24 training and 14 test attacks. And they are used for an IDS evaluation. It's developed in the Solaris, but the problem was that it was developed using Solaris over a Solaris working environment, that is sun environment. And nowadays, most of the systems use Linux or Linux variant. So therefore, KDD CUP dataset was introduced again with 41 features that are considered suitable for machine learning. So in view of the importance of reliable, several improvements of KDD family are now available, and they use a Unix or Linux operating system environment, which include ADFA, is a possible successor of DARPA KDD dataset. It is a contemporary penetration tests and hackers. And also have NSL KDDs, another datasets in 2009, which eliminate one of the efficiencies of us. There were some huge number of redundant records, so therefore it biases the learning algorithms. So they prevent them from learning sophisticated associated with the user to root to remote. The intuition data sets, internet traffic archive that is there, which is 2014, is a repository of deep and widespread access of network traces and internal network traffic, but developed by ACM Sigma and other reliable data predict. It is used by defense, US defense against cyber attacks, threats, Qaeda. For host-based intuition detections, this is host-based means it is only not for the network, but mainly on the servers on that. And so as I said, KDD used 41, it has 41 features, 6 types of attacks. And in a recent article, it will be, they have shown that it can get a 85% detection rate for the DOS attacks. The features that are measured are source by number of source bytes, destination bytes, long fragment, number field, logins, logged in, etc. And there are some open source tools for intuition. Some of you who are willing to design your intuition detection system can use these tools. These are called SNOT, which is probably most commonly known or used. It is maintained by Cisco, though it's an open source. It runs on different platforms on Windows, Linux, and is able to analyze real traffic. So SNOT will operate in 3 modes. One is called the sniffer mode, in which it sniffs the network to find out to get the network traffic data. Packet logger, so it will log the network packets that are being received, and then for intuition detection. So intuition detection is a set of rules called base policies. Functions of the sort is able to detect and many attacks like signature based and anomalies. These are waste fingerprinting, port scanning, server probes. That is this is commonly used in any of the system. Microsoft OS also has the server message blocks. Typical SNOT workflow which is used is the sniffer, which code sniffs the network. You have some preprocessor determine the packets or packet behavior, and HTTP login, port scan, and detection using rules and rule sets, and output is set of alerts and logs interface. So there are other tools like Zik and Surikata that support the real-time intuition detection and prevention capabilities of it. And so unlike the network behavior and malware detection on these labeled data set is as well as any look for. Therefore, the task of creation in universal algorithm cannot happen for any type of behavior analysis. That are commonly used are regression, classifications of group of different users, and like clustering unsupervised to separate malware detection on secure email gateways or for malware detections. And clustering is a groups of users and detect outliers helps in some cases. Have also been used to compare business process and detect. In general, they are the examples of tasks or in the process area, regressions predict the next action. So business processes, since they will differ significantly, personally, you can look at the frauds in banking or credit cards, and though they have some commonality, they also have a difference when you compare it with the plant or float manufacturing process. But the underlying process is totally different and demand not a lot of domain knowledge. So while developing a machine learning based fraud detection system in general, you have to incorporate what you call the feature engineering. Is a recent advances in machine learning. The way we want represents the data to detection algorithm And it is essentially to achieve acceptable result: true positive, false negative. And so host-based encryption in a computer system detects the suspicious activity in a computer itself, which can include intrusion by external actors such as misuse of resources of networks. So therefore, you need to have the log files, which are system logs, which maintain history of operating system called stresses. These tools can monitor the log files and maintained by database servers. So HIDS attack change the mode to registry settings and critical system and configuration, log and content file, alerting to any unauthorized anomalous attempts. So again, HIDS, host-based, is not, these are not network, these are host-based, meaning some server or some machine in which you have installed the software. HIDS can be signature-based and anomaly-based. So running on a signature-based detection network, somewhat similar to the antivirus operation. So you have a system, you have an antivirus, which search for bit patterns or the programs which are which the virus did, computer virus detections. So anomaly detection used in the sequential, but here is a problem. You need a sequential in nature system calls. So this, if you look at the system log files, not that the calls are made just one and then next packet can be anything like a network. Here, after you can change mode, execute the change mode after you have opened the file. If you have an access to the file, then you open the file and change mode. If you have now know the Linux command change mode, you can change this mode or that whether you can modify the file or not. So you must have a change mode of privilege. And so this is sequential in nature. So you can have an unauthorized login. You can have a log. System log can contain unauthorized logins attempts. Privilege escalation, as I said, I want to change my mode from common user to a root or super user. Modification applications of binaries, data, and configuration files in the system configurations I can change. You can install some unwanted applications like rogue programs, which will then act as a take over your system and then becomes itself an hacker. So these rogue processes and critical cells that have been stopped or failed to run. Some of the commercial open source tools are Tripwire, which is probably most commonly used in all Linux installations. And it ensures data integrity, helps system administrator to detect alteration of system files and notifies them if they are corrupted or tampered files. Then we have the Grandfun, which is POSIX systems, all kinds of Linux use, including Windows also. It can be used, and then open source security event advisors. So components of HIDS development as like an IDS is the data collections. So we have the feature selection. Some data units are system calls for a process, rows and a row is used in attributes of a feature by decision engine. Here is an algorithm for heuristics to decide given data is represented as a feature vector, is believed to be an attack or not. It is categorized as misuse and hybrid misuse detections again can be signature based or malware based. And we have the audit trails provide visibility of network connections, and audit can be event occurrence like different audits events that occur. it can have like say CPU time, how much CPU time has been used by a comment, duration of the comment, event combinations and multiple events frequencies even, and system call IDs are used to basically look at the system log, which can be like comments like open, close, read, write, etc. And system calls. So Linux manual has list about 300 calls, and such process produces sequence of system calls. For instance, many variations, you can use n-gram features or hidden Markov model of sequence calls are configured to produce normal and attack scenarios. So you compute the HMM of your normal behavior from the available data of the system syslogs, and then when the new attack comes, then compare the recompute it and see whether there is a deviation. And many anomaly detections are quite sensitive to the length of the sequence, and with 6 to 8 grams are often being strong choices. Short sequences provide less computation but are bypass the longer ones. So this is what about the HIDS. I'm almost coming to the end, and in fact I have exceeded my time. And so this is about this. I'm not going into the database part, database security when we talk about it, and then some of the references are the classic network book, the book that's there, the Stallings or Canadian-bound and books on networks, and there is an excellent review paper, anomaly-based review thing in IEEE transactions. These are very recent ones, and this is the fairly new one, 2019. Survey of Intrusion Detection Systems over Host Data. This came out in Asian Survey, Computing Survey, and so that's all about what I have to say, and some references. There are several hundreds and maybe more references available, but I've just tried to give you the basic ideas of the networks, network attacks, how they take place, how to protect them, and what is intrusion detection, and how do you use the classical data about the public data sets to compare your system you develop against the of the intrusion detection system you develop. How good is your algorithm? You must compare it with some of the existing standard data sets like KDD or internet traffic data set, because without that your algorithm will not be acceptable much in the so that's about it. Any questions or anything you want? Thank you.
Thank you, sir. Thank you very much. So, those participants have any questions, please email us because we are exceeding our time.
I've given you the references and the data sets you can look at. These are publicly available. So it's not in Kaggle, but these are standard data sets on which you can test your program. And how to do it. Basically, the network means sniff the network, collect the packet, analyze the packet with some features normally used I have listed. There may be other features you can, and then use a statistical to find the mean, variance, etc., of the normal data set, provided you have a labeled data set. If you don't, then you are in little bit of trouble. Then you have to first use an unsupervised learning technique to partition the data sets into clusters and outliers. And for each cluster, you can create your own model and go on with it. Okay?
Thank you,
So
sir.
is that okay, or it was too heavy, or too small, too little, or too much on the superficial level? I didn't go into the programming part. There are standard libraries available. I've given you the snot, but there is a open source C library, open source stack C library. It's not essentially use a C, also in Python for those kinds of activities like snip or packet. And then you can use a smart detection algorithm if you don't like SBM, or you can use a KNN algorithm clustering for clustering techniques. In fact, some of the papers I have referred, they use KNN and then go into the this. But only thing you must remember that it is, you must be able, your algorithm or system must not take too much time if it is going to be real-time use at all. We have worked at IIT also used the game theory to detect credit card frauds. So basically, you as a system plays a game, computer game, as a like you do in computer game, one-on-one game, and try to see whether the normal behavior, you build the computer which is built on the normal behavior, plays a game against the intruder, and when the intruder tries to maximize his profit, and protection system wants to minimize the loss. And that game theoretic model works fairly well, provided, of course, you have a good data set for credit card frauds. And unfortunately for us, we could not get very reliable data sets, but still we did somewhat. Okay.
Thank you very much, sir. Our next speaker is our director, Padma Professor Ajoy Kumar. I think most of you have gone in for a long time. So I will request Professor Ray to start his presentation. So Proceed, could you please check with Professor Ray over phone?
Yes, I will. I will.
So Chandranath, if the students have any question, you correct them.
Yes, sir. So still, if any student have any question, can ask right now or email us. We will forward to Professor Ajoy.
Yes, Chandranath. So,
Yes, sir. Good afternoon,
so
sir.
Professor Majumdar's lecture is over.
Yes, sir. It's
And,
just now he has finished.
Okay. So then shall I start?
Yes, sir. Yes.
Okay, so very good evening, good afternoon, everybody. So I'll be talking on, let me just go straight into the topic because, so let me go to the, so I'll be talking on cyber security. Now, cybersecurity, as you know, is one of the most important, and it's quite a vast topic. And can you see it?
Not yet, sir.
Present your entire screen, sir. Yeah, now we can see.
Sir, it's visible. Yes, sir.
So is it okay now?
Yes, sir. Yes.
Okay, so let's, I will rather go at a much lower level, and let's see that, I mean, it will be mostly in the form of a storyline. And the cybersecurity, as you know that, okay, the computers, they first came in, 1940s, if you consider. And the person who had contributed, very significantly was John von Neumann. And he was not only the father figure of the modern, stored program computing, concept, but then again he was the originator of lots of new ideas, which was even in late 40s, Neumann, he had predicted. So, and one of them was a possibility or probability of having a big problem, security being a big problem in the time to come. And today, as you all know, that cybersecurity is indeed one of the most important problems. So I will now, the first time, 1950s, 60s, so computers were at its infancy, so to say. And in 1970s or say late 60s, one of the important work which was being done was by American Defense. And that project, as you all know, is ARPANET project. So in 1971, in ARPANET, some of the people who were using ARPANET, it was the American Defense project. And when they came in the morning, they saw on their screen a very interesting phrase, "I am the creeper, catch me if you can." Now, nobody had any idea that what is this? What is the meaning of this? So this was developed by a group of three. In fact, they are all ARPANET scientists only, Bold, Beranek, and Neumann. So Creeper wrote a program which was a worm. And what is worm? Worm means it just flows through from one machine to another, a type of computer virus that replicates itself and spreads to other systems. So everybody saw it was a benign kind of the first computer, virus, so to say, or worm. Worm means that's also a virus, but then it can propagate. It can replicate itself throughout the network from one machine to another. It was not malicious at all. It was just a fun. But then this fun worm was the first virus which was created. So everybody in ARPANET, all the other scientists, they came to know that, okay, this was a piece of program which these three people, they had written, and they gave the name, it was a Creeper, program. Unlike today's malicious viruses, all Creeper did was simply display the message. "I am the creeper, catch me if you can." So in 1972, an American computer programmer. And as a matter of fact, he was one of the inventors of emails, Ray Tomlinson. So he was also working for BBN Technologies at that time. So he saw this idea where, you can sort of create some such kind of a message and then it can propagate through. And he liked it. He tinkered the same program and which is basically self-replicating. So it's propagating and self-replicating. So the first computer worm, so he named the program Reaper. And the first antivirus software which would find copies of the creeper and delete it. So it is the antivirus software. That means whatever creeper, in whichever machine you find the copies of creeper, so this program will delete that. So that is, in a sense, the first antivirus. So in 1983, in between, a lot of people, they had developed a lot of interesting kind of pieces of programs. But for the first time, the United States patent for cybersecurity came in September of 1983. So this was important in the history of cybersecurity. And when the patent for cybersecurity came in the September of 1983, and this gentleman, he was granted US patent for his brilliant work. And this is not a single gentleman, but then three people, Rivest, Shamir, and Adelman. Now these three people, they for the first time talked about a model which I will be presenting in course of my lecture. And this was a cryptographic communication model. So encryption and decryption, how it can be done. And although they did it in 76, 77, remember, but then the patent, usually US patents, it takes a lot of time, 3, 4, those days, 5, 4, 5 years. So the patent was granted in 1983. And this is RSA algorithm is still one of the most important, this public key cryptographic algorithm, which will be, which we will, present in course of time. So cryptography is the bedrock of modern cybersecurity, because for security, for ensuring security, you need cryptography. So in 1988, again, another American computer scientist, in fact, most of these initial works were done in United States only, Robert Morris. So he had a very funny and peculiar idea. He wanted to check the size of the internet. So 88, internet was at its infancy. Even in India, we didn't have it. And only America and North America and then some European countries, China, Japan, they had. Even China also possibly didn't have it. So Robert Morris, he wanted to check the size of the internet. So he wrote a program for testing. Now, how to find out that what is the size of the internet? So it went through the networks, invaded all the Unix terminals, and copied itself. Again, there was an idea of copying, replicating that program, and it became the first famous network virus. And this was known as, all of them were worms. Worms are self-replicating virus. So this was also a worm known as Morris worm or internet worm. So for the first time. So Morris worm could infect a computer multiple times. And then this was really a catastrophic thing, because each additional process would slow the machine, quite considerably. So what happened was the machines become very, very slow because it was infected, like our, the current day virus, and eventually to the point of being damaged. So Robert Morris, for the first time, in the whole history of cyber security, he was, sort of a first information report, FIR in India, as we call it, and he was charged under the Computer Fraud and Abuse Act. The act itself led to the founding of the Computer Emergency Response Team. So people, they thought that if this continues, then it will be a real big problem, because it was truly one of the most damaging worms, because the initial worm, as we said in 1960s, it was not damaging, just simple one message. But then this was a real damaging, worm. So they started the Computer Emergency Response Team. So this is a non-profit research center for issues that could endanger the internet as a whole. That's what was the major problem. So with now gradually, security becoming a major problem, although there was very little concept of security even those days. So the first conference on this was on 1993. It was organized, known as DEF CON, by Jeff Moss, who was originator. And this first conference started in Las Vegas with only 100 people, those who attended in 1993. That is about, say, 27 years back. And today, the conference is attended by over 20,000 cybersecurity professionals from around the world. So every year, this conference, international conference on cybersecurity, takes place. So in 1995, a fantastic concept came, because the people in general, they felt that until and unless we have got a security protocol, and this whole problem of cybersecurity will remain there. And in 1995, today everybody is aware of secure socket layer, SSL. And it was first started in 1995. So it was a security protocol that allows people to do simple things like purchase items online. Today we are continuously doing it. So when we do it online, any kind of procurement, so it is through the secured sockets layer, SSL, Internet Protocol. So Netscape was the first company which began developing the SSL protocol. And it was only after the National Center for Supercomputing Applications released the first web browser. So in 1995, Netscape released SSL 2.0, which became the core of the language for securely using the web. And this was also called as HTTP secure. You will find that HTTPS, that means it's a website which is very, very secured. And if it is only HTTP, that is not very secured. So when this S is there, that really means that it is a hypertext transfer protocol secured. So that was started with Netscape, who had in 1995-96, after the release of SSL 2.0. So now your communications with your browser here, in this case, will be encrypted. So the whole concept of encryption, it came in 1970s, for which, as I said, that in 82, 83, SS, they got the patent. And in 2003, the first anonymous group of hackers were born. So far it was only 1-2 persons. They were making fun, and none of them was, professional hackers, and they were really not hackers. And it was only out of not only fun, they wanted to do some experiments and all. But then in early 21st century, a group of hackers, they, started their business. The group had no leader. So it's not that under the leadership of someone, But then many online and offline community users, they formed this group. And this was really a hacker group. Together they exist as an anarchic, digitized global brain. Very, young people, quite intelligent, and wearing the mask of Guy Fawkes, the group gained national attention when the group hacked the Church of Scientology website, which distributed, this is known as a distributed denial of service attack. So this is, we'll come into the different types of attacks that can take place. So DDoS, denial of service attacks, is a very important kind of attack, and in a distributed environment, it is known as DDoS. Anonymous continues being linked to numerous high-profile incidents. So Anonymous, this was the hacker group. That means nobody knows that who is the member of Anonymous. Later on, of course, it was all known, and many of them were punished because in every country, cybersecurity laws became very, very stringent and all. But yet they operate in various forms. So to take care of everything, for protecting the privacy of the citizens, now a lot of things have been done, on the cyber security aspect. So before 2010, the disclosure of আমার একটা ক্লাস চলছে, একটু পরে আমি ফোন করছি। The disclosure of security breaches were considered highly unusual. So, but then in January 12, 2010, hardly a decade back, Google shocked the world when it announced Operation Aurora. So they said that there was a major breach on its infrastructure in China. This was a very, very important event. So Google initially thought that the attacker's goal was to access the Gmail accounts of Chinese human rights activists. Because initially they were wrong. Because during those days, if you remember, that there were a lot of human rights activists in China, and Google thought that, okay, maybe that the Chinese authorities wanted to access the Gmail accounts of these human rights activists, but it was wrong. Finally, the analysts, they discovered that the true intent was identifying the Chinese intelligence operatives in United States, who may have been on watch list for American law enforcement agencies. So it's very interesting, but the attacks had hit more than 50 companies in the internet, finance, technology, media, and chemical sectors. So this was a very important event in the history of cybersecurity. In recent years, this is all, you all know that there have been innumerable number of massive breaches, and which have hit the name brands like Target, Anthem, Home Depot. These are the kind of, big, those brand names in United States. Similarly, Yahoo, Marriott, many of them. So there had been, there had been security breaches there, compromising data for the companies, because these groups, that means the hackers, they, in many cases, they will always generally like to hit the companies and billions of consumers. But one interesting thing is that many people, they feel that, okay, I am an ordinary man, and so my machine or my interface with the internet, it is always a very simple affair. So nobody will do anything. So my machine or my system will never be hacked, which is absolutely not correct. It's not only that the breaches of security are broken in these big companies, but then even in ordinary citizens' privacy also are important for all of us. So cyberspace has become a digital battleground for government, business, industries, etc. So I will now go to the actual, thing, that is what is cyber security. A report by Risk-Based Security revealed that a shocking 7.9 billion records have been exposed by data breaches in the first 9 months of 2019 alone. Just year before last, 800 crores of records have been exposed. So it's amazing. This figure is more than double, 112% the number of records exposed in the same period in 2018. So every year, as you can see, that it's becoming a real menace in the internet world. So, let's now see that how the hacker can access your system. So there are several ways. One of the things which is very preliminary and which was the initial days, the hackers used to do it. That is, they may try to guess your password and then they can steal your password. Now, password guessing, everybody, you are always advised not to use a too simplistic password, but then you know that, okay, your password should be fairly complex enough. And that's why now about the password also, they are making some more stringent, requirements. Backdoor access is rather more interesting. So the developer, when they develop the system, they keep it open for debugging, because your machine, your system, it will always need debugging. So the backdoor access is open, and any hacker who knows about this will very easily enter your system through backdoor. Trojan is one of the things which we download and install from the internet inadvertently through emails and internet, different, websites. So that's why people say that you have to be very careful, especially when you are reading the emails. We'll come to these again later on. That, if you are not very sure, then do not open the attachments of an unknown, sender. So because it is likely, not that it will have the Trojan virus, but it's a very dangerous type of virus. Software vulnerability, which is known, may be exploited by hackers. So there are always the vulnerabilities. So sometimes the developers, they notify the security patches for plugging in the software vulnerability, but ordinary common men, they are not very much aware of that, and they become target for the hackers. So what does a hacker do once they access the infrastructure? Naturally, the first thing they do is they will modify the log file. Then they will try to steal the files. Then they may modify the files, because your files, not that they will do everything, but whatever, whatever is important for them. If it's for fun, then they can do anything. They may install backdoor. This is the most dangerous thing. That means, one, they can access your infrastructure. The hacker itself can install a backdoor. And through that, you can, through your system, they can attack all other systems which are connected to your system through various means. So remote access is granted through backdoor attack to the resources. That is the database, file server, everything. Through backdoor attack, they can get the remote access. So data theft, website defacing, this is very common. Many times you will find that the website of a particular company or a particular organization has been defaced. Server may be hijacked. So this is another, very peculiar and an interesting kind of, such attack. launches, this is the most, critical one, that is distributed denial of services. That is, as I was mentioning, that denial of service means it will be clogged like anything, your server, so that however hard you try, you will not be getting the services. Because, I mean, so many, so many multiple number of times they are, they are uh, recreated, and you are getting all the time the denial of services. So if you cannot do anything, then automatically the system will crash. And it quite often, it works, as I said, in distributed fashion. So they call it as distributed denial of services. I can come to it if time permits later on. Infecting website visitors, because when you visit a particular website, and if that website itself is infected, then you also will be infected. Your system also may be infected. So there are, lot of such typical threats. Compromised IoT devices. Now, as you know, that we all know that almost the number of IoT devices, it is increasing by leaps and bounds. So one prediction says that by 2040, there may be 75 billion of IoT devices. That means 7,500 crores. So it is an amazing number, and IoT devices are the weakest links in this whole chain, because many of the IoT devices, they are all compromised IoT devices. They do not take much care about the security aspects of all at all. So the computers are used by hackers to launch the denial of services attack. And once, there is some vulnerability in one or a group of IoT devices, then the entire net which is connected, the entire subnet that is connected with that, will also be vulnerable, and then it will create a havoc. Insecure web services. So this is another important, thing. Insecure network services, because it is not only that only your machine is infected, the entire network you have to think about. So one of the things is, nowadays we'll talk more in detail about the encryption decryption. So lack of appropriate encryption, that is the message that you want to send, it must be, encrypted in an appropriate way. Insecure cloud interface. So like IoT devices, again the cloud interface, that is a vulnerable area. And then there is every possibility of the hackers who will be on the channel, because hackers are always on the channel which is not very secure. So channel itself is insecure. So the cloud interface is one of the insecure points through which the hacking can take place. Insufficient security configurations, insecure software or firmware. So many of the things, and as you can see that these are the potential targets of attack by the hackers. So since time is less, I will not be, because already I think it's more than 5. So interruption attack by hacking the routers, because from source to destination through several routers the message is going. And then if the hacker can attack any of the routers, then it's gone. That means you cannot do anything after that. That means your entire this network will be inoperative. Attack may be on confidentiality. That means from source to destination, you are trying to send a message. Intruder is sort of a man on the middle. So he is the person who can get access to the message and then do havoc. He can change the message, as you can see. He can change the identity of the source, because you are the source. You are sending some message to your friend, and then the identity of the source and the authenticity of the attack may be, completely will be demolished. Integrity of the message is attacked means the message itself will be changed. so that it's not the same as it was you were supposed to send to your friend. So an explosion of high-profile cyber attacks targeting a wide range of prominent organizations across key industries. So as I said, that key industries, business houses, they are one of the major, points which the hackers always look for, because it involves a lot of, financial, juggleries and a lot of financial sort of transactions can take place through that. So many types of attacks, advanced persistent threats, industrialized attacks, insider threats. Many times, the attacks need not come from the outside. It can be from inside only. So it has become difficult to clearly delineate between various threat vectors of concern. That means you have to delineate, you have to see the nature of the attack. You have to classify those attacks. And then the attacks which are, important for the government services, for the enterprise networks and all. I can tell you that some Indian such hackers, one of them, he was a student. And I knew him. He was a student who was studying in that, there is one Thapar Institute of Information Technology, not Thapar. I've forgotten, because nowadays I forget the names. Anyway, he along with another student from IIT Bombay, they started doing the ethical hacking. So ethical hacking, as you know that the students community everywhere, they would like to have the ethical hacking, there will be a lot of seminars and all, and young people mostly they are interested in it. So so that student, he came to Calcutta, and then he went straight to writers building, and then he said that, look, I have got the complete information about your official secrets. And then in front of some of the secretaries, he showed that how vulnerable is your website. They went to WBUT. Those days it was West Bengal University of Technology. They went to the registrar and the vice chancellor, and it appears that they showed that, look, all your emails are with me, and how vulnerable is your website and your entire system. So it is to that extent. So I'm talking about, I think, 2014, 15, around that time. So naturally there are a lot of such, so they want to plug in the weak links for which the attackers or the hackers, they can, target and access your infrastructure. So what is important today is that the nature is continuously changing. So naturally the the dosage, that also will have to be appropriately with research. You have to take care of that ethical hacking. You have to learn the things that how the hackers do it, and you have to plug in. So emerging trends are in cloud computing, the mobiles, and bring your own device. This is, one of the common things, that in any organization, you are taking your own, devices for copying. So it further complicates the matters, because in many companies, they don't allow anything to be, because whatever you are doing, including your email messages, inside the company premises, some companies, they now say that it's my property. It's not your property. Whatever you do inside the company four walls, it is mine, it is the company's property. Because after all, everything is vulnerable to attack. So a very important thing, as you know, that Professor Majumdar was also possibly mentioning about the big data, which can be stored in any space of data set. And then the whole art of hacking, cybersecurity threats, it is gradually taking a different kind of shape altogether. And so secure sockets layer is one very important stuff. Appropriate encryption is another very important thing. And the knot of data set and application programs together. That means big data means, as you know, that it is of huge quantity and it's completely different, data structures. It may be structured data, unstructured data, semi-structured data, and then it may be of different types. It may be creating huge amount volume of data in no time. That is, it is coming with huge velocity. And naturally, in many cases, you may like to do the real-time processing. Interestingly, the data, that's a very interesting, economic valuation. That is, the more older is the data, its value reduces. Because that data, it is more vulnerable to be changed. So it's always important, and today's world, the whole technology is moving in this way, that you have to process the data instantaneously. Now with big data, processing such a huge volume of data online or in real time, that becomes a real problem, and newer technologies are coming up today. So one of the things is, when you are encrypting the data, for any kind of encryption, you need the encryption keys. I will come to that. And you must separate the secret key and the encrypted data. They must be separated out. And it is important that there are two things. One is your application program. The other one is your data on which the program will act. Now, there is a not means it's a combination of data set and application programs with appropriate encryption. And that only with appropriate encryption, that only can protect the big data together. So network access security model, I am not going into it because already again 15 minutes over. Common threat vectors, distributed denial of service attack, I have talked about unauthorized, man in the middle attack, so this is very common. Code and SQL injection attacks, privilege escalation, you do not have the privilege, but then the attackers can penetrate your network by escalating their privilege levels. Insider threats is very, very important, because it's not only that it comes from outside, insiders also may take part in it. So maybe that another time we can talk about all these things. So this is the summary of how you can do it. But then the major thing I haven't yet come, and that is since time is less, that is data encryption and decryption. So cryptography is one of the major areas which must be studied when you talk about the data security. And cryptography means the main security initiatives in data transmission. There are three important things while you are transmitting your message. What are these three things? One is authentication. Authentication means that it allows for the verification of a message's origin. I am sending the data. So authentication means that I am the sender, that must be authenticated. This is a very important point. Integrity. Integrity provides proof that a message's content has not been changed since it was sent. I have just sent the message. After that, the message's content must not be changed. That means the man in the middle attack, or say any other kind of attack, should not be, because after all, the major problem is the channel of communication is very insecure. Anybody can get access to the data that you are transmitting, the message that you are transmitting. So important thing is that you must ensure that the integrity of that message's contents must not be changed. And non-repudiation of ensures that the message sender cannot deny sending the message. I can't say later on that no, I haven't sent this message. Whereas the attackers will exactly do that. Attackers will try to camouflage your source identity, and it will mean that, okay, somebody else is sending. Or sometimes in your name, a lot of emails will start going through. It happened to me because once my machine, my email was hacked. And then a lot of people, they started telling that, in fact, from your email, that somebody needs money, as if I have written it, that please send me money immediately. As if I am not in India, something. I mean, many people, they have got this kind of an experience. So the sender, the whole cryptography must ensure that the sender's, his identity should remain intact. So cryptography is the major important thing in data security. So two types of data encryption. One is known as symmetric encryption, which is very common, which is the first type of encryption. But then now today, with the complexity of the security and encryption processes increasing, so we have got asymmetric encryption. Symmetric encryption is also known as private key encryption, and asymmetric encryption is also known as public key encryption. So what this means, symmetric key means that there is only one key, because when you are transmitting the data, then the main message is known as plain text. Now that plain text, that is the message that you want to transmit to your friend, it is encrypted. Now after encryption, how do you encrypt? Encrypt with the use of a key. So you need a key. Now if that key is a private key, then using that key I can encrypt the data. And then the data is encrypted. Encrypted data goes through the insecure channel. Channel is very bad. Now the attacker who is running, who is just sitting in the middle of the channel, can access this message. But then this is encrypted message. So naturally, we have to ensure that even after getting that encrypted message, he cannot do it. Now what you have to do is that using the same key, the receiver, your friend, he can decrypt the message to get back the original message, because encryption gives you an altogether different form of the data. Decryption is just the opposite process where you get back the original message. Now the major problem here is that suppose you are using a single key both for encryption and decryption. Now how your friend will know about the key? So you have to tell your friend that, okay, this is the key I will use for data transmission. In fact, this kind of things, even in the schools, a lot of students, they do, because they find, suppose some classes are a little bit boring, so they will write a 2-line something, and every letter will be replaced by the next letter in the English alphabet. And then he passes that to his friend. So his friend decrypts it, and he comes to know that, okay, his friend has written that, oh, I am not understanding what is being taught. So like that, some kind, or when will you go to play? So even if the teacher comes, the teacher will not be able to understand that what is being written. So this is known as cipher text. That means after the encryption. So first of all is the plain text, then cipher text, and then after the decryption, you again get the original message, that is the original plain text. Now in this whole thing, the symmetric key encryption obviously is much faster than asymmetric encryption. But the sender must exchange the encryption key with the recipient That means your friend must know that key. Now, you cannot send the key through the insecure channel. Then the attacker who is sitting in the middle, he can get the key, and once he gets the key, he himself can decrypt it. He can get back the message. So one of the things is, although the symmetric key cipher is very fast, is much faster than the asymmetric key, public key, but then symmetric key ciphers are not good so far as the encryption is concerned. So for securely distribute and message, huge quantities of keys will be required in symmetric keys. For example, you want to transmit message to 100 of your friends, and your whole group, 100 people, they want to transmit the messages. So how many keys will be required? It will be NC2. That is 100 C2, 100 factorial 100 into factorial 99 by 2. Now, this is an abnormally large number. So you cannot have controlled so many keys. So asymmetric, the symmetric keys will require a large number of keys, and then those keys also will have to be transmitted through the insecure channels. So on the other hand, if you have got asymmetric key, then asymmetric key has two keys. One is known as the public key, one is as the private key. Public key is for everybody to know. The hacker who is sitting in the middle, he can access your data, and he has the public key with him. But only with public key, you cannot decipher whatever is written. So this great work by Rivest, Shamir and Edelman, so this is one of the best algorithms, although a lot of other algorithms also has come up nowadays. So before this came up in the year 1977. Before that, there was another interesting paper in 1976. That was Diffie-Hellman key. This is very interesting, another, kind of encryption algorithm. And just the next year, these three people, they are all, from MIT, Rivest, Shamir and Edelman. So they published this paper, and which is still being used as one of the major public key encryption algorithms. So since, the time is, I have taken, it's now more than 5:30. So RSA algorithm is very, very interesting algorithm. Maybe that sometime later on we will be talking. This is the key generation. The major thing is how do you generate the key, and it depends on the prime numbers. I will not go through the algorithm as such. There won't be any time. Next time we can cover this. And the last one is, the steganography. This also many of you might have heard it. So this is a kind of, the secret messages. This is not encryption. Encryption and steganography, they are absolutely two different things. Here, the message is hidden under the cover of a cover image or text or whatever it may be. For example, you have got a letter to be sent to your friend, and that is very, very, it is a private letter. So you can have a covering image in which you can embed your text message, and only your friend who knows that, okay, this is how the encoding was done by a key. Here also you need a key. What is that key? I will talk about it later on. So once the secret message is covered under, suppose this cover file I have written on top, this is nothing but an image. It may be an image. It may be a video. It may even be a music. Inside your music, somebody has sent it, and you are listening Rabindra Sangeet, and inside that Rabindra Sangeet, there may be a beautiful letter which is written. A very private letter. So steganographic encoding is very interesting process, and the object that you get is from stego object. Now this has been taken from that edureka, that is one from the net, because I didn't have time to make the PPTs. So through the communication channel, one is the steganographic encoding, the second one is the steganographic decoding. So once it is decoded, then the original message can be read by the receiver. So, so as I was mentioning that this is one of the things. So cover objects may be text steganography, it may be image steganography, video, audio, network steganography. This is also very interesting. So I will not go to, the different kinds of algorithms which have been used for the image steganography, how you can hide your message inside an image. And time is already, half an hour past. So thanks. If anybody has got any question, you can quickly ask me any question that comes to your mind. And then I will stop because there is another lecture after this. Yes, Saptarshi or Chandranath.
Yes, sir. Yes, sir.
Saptarshi, so
So I would like to ask the participants whether they have any questions so far on the last session.
any question? Because I could not cover all those in detail because steganography itself will take about say 4 or 5 hours. And encryption also is the RSA is only one of the encryption algorithms. There are at least, 12 to 15 encryption algorithms which are equally powerful now. Mainly in the public key encryption and also in the private key encryption. So I wanted to talk about it since this is one of the most common encryption algorithms. So similarly, cryptography is a very big chapter altogether, and you need a lot of statistics. So it's based on the number theory, and more precisely on prime number theory, and still more precisely very large prime number theory, because all these things. The situation should be such that in the lifetime of the hacker should not be able to decipher the message which has been encrypted. And that is possible by using the keys, which are not only, the prime, but then very big prime numbers. Yeah. Okay, so any question?
Sir, is that worm is a basically
Yes.
that kind of thing? Terminate, stay, and resident kind of thing. Is that worm is basically a TSR?
Hello?
Hello? বলছি স্যার টিএসআর কি একটা টার্মিনেট স্টে রেসিডেন্ট কাইন্ড অফ থিং যেটা আমরা সিতে প্রোগ্রামিং করতাম যখন?
হ্যাঁ আমি ভালো শুনতে পাচ্ছি না। তো আর মানে কিছু কি আছে? তোমরা একটুখানি ওই যে চ্যাট বক্স একটা আছে না?
Yes, if the
Can you
participants have
hear
any
me?
question,
Can you hear me? ওই চ্যাট
Yes, sir.
বক্সে একটু লিখতে পারো তো। আর না হলে আমাকে ওই মেল করে দিও যদি মনে হয়। You can send me a mail.
Okay, sir. Okay.
Okay, so now I think that there will be another. Yeah. Chandranath.
Yes, sir.
Arun to আছে।
If any participants have any question, then they can email us. We will forward to the respective speakers.
They can forward to the respective speakers. Because Prof. Majumdar also is here. And then who is the next speaker?
Today the session has finished, sir. Tomorrow we have 4
But then
sessions.
you said that today there is another one.
No, total 3.
Oh, total
So
3.
one was, yeah, one was Dr. Shyama, then Professor Majumdar, then yours.
Acha.
Tomorrow we have 4 sessions.
Huh.
One is about scalar category theory, then role of access control modules in system security. Then there is sneak peek into the RSA algorithm. Then one hands-on session on client data.
Okay. So the participants, you tell, give your feedback. I mean, is it okay or because we are trying to make it simple, because majority of you are in, they are in 4th year or 3rd year, 4th year, mainly participants.
Yes, sir.
Yes, Akash, you are Akash, Meghna. So you are in which year? 4th year. Okay, so Meghna 4th year, Akash 4th year. So how are you liking this? So should we move at a lower level, or because we were not very, very much, because we were.
Akash is saying informative session. Rajbir is asking a question: is that WARM is a TSR program?
Now, worm is, I mean, anything that is self-replicating and which gets transmitted, that kind of a program. Acha. So Meghna, you have liked it. So, so you are from which universities? From which engineering college? So you can give your feedback if you feel that, okay, you need to know more about any subject in related to, computer science, mainly data science, or maybe that interface with electronics. So you can inform Professor Chandranath Adok or Professor Saptarshi Das, and then we can arrange accordingly. We can arrange the webinars like this. If you want that only on a single topic, we should arrange that also you can do. The whole idea is that during this pandemic time, from our institute, it is JIS Institute of Advanced Studies and Research. So this is the newest institution in not only in Bengal, but maybe in the entire country, because we have not even completed 2 years. And out of which almost 1 year, 4-5 months was in COVID. So we have, we have professors like Professor Majumdar, Arun Majumdar. So he is one of the, real authorities. He was the deputy director of IIT Kharagpur, dean, head of the Department of Computer Science and Engineering Department at IIT Kharagpur. So we have all our faculty members. They are extremely good, I should say. And we will be, recruiting more faculty members. Because of this COVID, a little bit, we are running late. And so, yes, ANN is very important, right? Artificial neural network is very important in data science. And that's what I think Professor Majumdar has also talked about, the, AI in data science. And so, so you can write down through your chat box that in which area you would like to have the courses. And second thing is that should it be at a preliminary level? Because I thought that, okay, because my whole talk was more or less on a preliminary level, and then, just historically how the things are evolving. So if you know about the subject, then you can write that no at an advanced level. Or if you want that, okay, it should be at a preliminary level, fundamentals level, then that also you can write. So GAN and deep learning, okay, so that Rajbibor is our student, okay, but mostly I wanted to know from third year and fourth year. The Rajbibor GAN will be taught in the advanced, our machine learning course. That is one of the most important areas, that is generative adversarial network. So that will be taught in any way. And so participants, you can give your choice. Meghna, preliminary level is requested. Okay, so that's fine. Chandranath, you note down. So preliminary level
Yes,
in
sir.
which area? All these data science, all the areas.
So I request the participants to have a look on our Facebook page where we are updating the past workshops links. Like in the YouTube, we are also updating the videos.
Yeah. So
Previous videos you can find there,
all
and
the
whenever
from our
whenever
department, all the participants will be given one certificate, isn't it, Chandranath? And then our
yes sir,
brochures
yes sir.
and all the videos. Okay, second year GIS, very informative session. Okay, very good, Namrata. Good that at second year you are okay. Cryptography and networking. Okay, especially. So that's very good. We will talk about it, Meghna. Yeah. Then others, Spandan, Rohan. So if you have got anything, any feedback that on which areas and all, so that will help us. Okay, so Pranay, BCA second year, okay. So Pranay, yes, so you are in second year, so one more year. So that's very good. So you can write, your requirements and at what level we should conduct it. And another important thing is the basic fundamentals. If you feel that in computer science also you would like to stress more on some of the computer science subjects in your final year, that also I think Professor Majumdar, Chandranath, Saptarshi, we can Abhishek. So Shaun, Devnath, need a session. Shaun, yeah, I could not see. Need a session on Shaun?
Networking, sir.
Networking. Okay. So that's good. Networking. Okay, networking. Okay, good. Shochin is first year, very good session, very good. Okay. Niloy, cryptography and networking. Okay, Niloy, very good. We'll keep this in mind. Yeah. Chandranath, তুমি একটু নোট করে
Yes sir,
রাখো, খুশি।
yes sir. And keep looking our Facebook page where we will update you accordingly when the new webinar or
Yeah,
workshop
yeah.
are coming.
Or you can tell your friends also. This is only out of our commitment for the students. And please, cyber security, okay. And be in good mood, because we think, we feel really bad for you. You cannot go out of your home for 1 year, more than that. you are stuck up inside your home, no friend, no class, no laboratory, nothing, only online, whatever we can do. So if necessary, then in fact, if you need any other thing, Professor Majumdar is here, we can discuss about, your other requirements like your jobs and what kind of subjects you can study, what will be taught in which area. So anything and everything, if you feel that you need some, again, basics or the preliminary things in computer science, like say data structure, somebody needs it. So this will be small, maybe that for 3, 4, 5 hours, because we cannot keep on. This cannot replace your regular classroom. So cyber security and job opportunities. Okay, very good, very good. There will be a lot of job opportunities in cyber security because this is the most upcoming area. Because the whole world is now fighting with COVID and fighting with these hackers. It's equally Namrata. Okay, so that will be good. So these are both are equally important and equally difficult. Okay, for your blockchain and cryptocurrency. Acha, Rajbibor, we will be covering it in your classes next semester. So, yes. So if no other question, then Amrita Bakshi, yeah. What did you write?
Is it augmented reality?
Augmented reality?
Yes.
Augmented reality.
Okay, augmented reality. That's a very, very important area. Both virtual reality and augmented reality. So theoretically, we can talk about it, but then we do not have any systems here. In IIT Kharagpur, we have got a very big facility in our industrial engineering department that is on virtual reality and augmented reality laboratory. In fact, there you can do a lot. I sort of for more than an hour, I had operated a crane. Only thing is, you have to be a little bit, stable. Your nerve should be a bit stable because continuously things will rotate and all around you. But then using that, you can also learn and you can do a complete, for example, inside a shop floor. Every bit of it, you can have a 3D video, and from there you can generate the complete 3D environment inside the shop floor where, for example, the lift is being operated or some machines are being operated, or you are trying to, trying to teach a person how to piloting an aircraft. That is very important. And so this is interesting. We can also arrange, yes, on augmented reality and virtual reality, we can arrange a small, maybe that about 3-4 hours lecture. Surely. এটা কি লিখলে আমি ভালো চোখেও দেখি না কি লিখলে
So machine learning and its application in cybersecurity.
Oh, machine learning and its application in cybersecurity. Very good. Surely. Machine learning, we had a specific last year or last time we had arranged a 2-day webinar series, no? Chandranath or Saptarshi?
Yes, sir. So we have shared the link in this chat box. So you can
Okay.
go through that.
And if you need again in more detail about ANN, artificial neural network, you can. And if you want to study here in our institute, I can tell you that this is going to be only thing is that because of Corona, this our new institute, we got a little bit, because we could not come out of our, so it was all online. Once things regularize, I'm sure that this will be one of the best centers. Okay, so then if no other question, then all the best to all of you. Okay, so
Thank
all
you,
the
sir.
best to
Thank
all
you
of
very
you,
much.
and yeah, be happy, stay safe, and feedback, Meghna. Okay. Stay safe and be happy. That is very, very important. Do not be stressed at all. And do not be upset also. Remember that this is only a very small phase of your life. Future will be very bright. Future will be very happy. You all will do very well. And have that positive, mindset. And you will do very well. Okay. Okay. Okay, then, Chandana, then you please join tomorrow. Tomorrow at what time?
So same time, 2 p.m. The new link has been already shared.
Yeah,
Tomorrow is the
feedback
separate.
form, Professor Chandana, Professor Adok may send you the feedback form. Okay, so tomorrow at what time?
Same time, from 2 p.m. to 5:30.
Okay, so tomorrow please join at 2 p.m. Okay, so all the best. Wacha, if you have got any feedback form, Chandana, you can share with them tomorrow.
Yes, sir. Yes.
Huh? Okay.
Thank you, sir.
Yes, Namrata, you will get certificate. Certificate, our brochure, and then what all we can give. Okay, because from feedback we can, okay, Namrata, thank you. And we can really tell you, give more such courses, small short courses on the weekends. Okay, Saptarshi Chandranath.
Yes, sir.
Yes, yes, sir.
Okay, all the best, Akash. Okay, all the best. তাহলে আমি লিভ করছি।
Yes, sir. Thank you very much.
Thank you, sir.
So we are in the session. Thank you all. See you tomorrow.
Thank you, sir.
Thank you, sir.